All right, here is some examples on how to use the angular velocity equation. All right, so what we've got so far is theta final equals omega t plus theta initial. Okay, so remember that's just like your y equals mx plus b from the graph, which is also like the linear average velocity equation. Okay, so that's all exactly similar. All right, one parent stands on one side of a merry-go-round, the other parent stands on the opposite side. Their child rides the merry-go-round and takes 15 seconds to travel from one parent to the other parent. What is the child's angular speed in radians per second? Okay, so these are pretty simple, but you really want to get in the habit of first drawing some kind of a picture. Okay, so we have like the kid, and then one parent, another parent, and then the child is going to go around here in 15 seconds, halfway or something, right? You also want to make a list, all right? So it's going to start, we'll assume it starts at 0 radians, all right? And it ends halfway around the circle. You need to know is pi radians. Hopefully you remember that from math. The time is 15 seconds, and the omega is question mark. All right, now these are super simple, I get it, but you really want to get in this habit of writing out your unknowns and really being methodical about what you do, okay? Especially because on the actual AP test, depending on how it is, there's a lot of just manipulating equations and not a lot of answers per se, okay? All right, so if I write my equation, then I'm going to go ahead and write it like this, okay? Delta theta over delta t. Okay, so my delta theta is pi radians in 15 seconds. So pi over 15 radians per second. Wow, that was so amazing, right? Okay, I mean, that's like a super easy one, all right? But that's the idea. So you really want to think of it. Don't let the rotational motion of it freak you out. Just think of it. It's just like linear motion, but it's around the circle. All right, that'll serve you well for later on, okay? All right, the blades in a blender rotate at a rate of 5,000 RPM, which means revolutions per minute, in case you don't know. All right, and the first thing we want to do is find that in radians per second. So if we have 5,000 revolutions in 1 minute, you can do this just like you would do in chemistry. All right, so we just want to... 1 minute is 60 seconds, and 1 revolution is 2 pi radians. This is an important one, okay? All right, so I'm going to have 5,000 times 2 pi divided by 60. I'm not doing that in my head. 5,000 times 2 times pi divided by 60. Okay, so 523 radians per second. Okay. And then through what angle do the blades rotate in 10 seconds? So we're going to have delta theta, okay, time 10 seconds, and then the omega is 523. Okay, so omega is, well, I probably don't want to write it that way. You write it in either way. Delta theta, omega t. Times 10 seconds, so 5230 radians.